In this video, we're going to be solving a trig equation, specifically one with a cotangent and a cosine. So here we've got solve the cotangent of x times the cosine squared of x equals 2 times the cotangent of x. So we're going to begin by getting everything to the same side. So we're going to subtract a 2 times the cotangent of x from each side, which is going to give us a cotangent of x times a cosine squared of x minus a 2 times a cotangent of x equals 0. From here, we can see that each term rather, has a cotangent. So if we factor out a cotangent, that leaves us with a cosine squared of x minus 2 equals 0. Because the 2 is still technically from our red piece, we can leave that there. From here, we can use the zero product property, which tells us that the cotangent of x equals 0, but also that the cosine squared of x minus 2 also equals 0. So let's go ahead and finish solving our right-hand side. So in this case, we would add 2 to both sides, and that would give us that the cosine squared of x equals a 2. Then we would square root both sides, and that would give us that the cosine of x equals a plus or minus radical 2. So to finish solving our solution, we need to look at our unit circle, and we're going to try and find where cotangent equals 0. Now remember that cotangent is the x value over the y value on the unit circle. So we want to know, where can that happen? And it's really only going to happen if x equals a 0 in our unit circle. So we're going to find all the places that x equals 0. And we see that that happens here, and that happens here. And just like tangent, cotangent only has a period of pi. So we'll ignore anything down here in the third and fourth quadrants, because we're only existing between 0 and pi. So here we can see that the solution to our cotangent of x equals 0 is that x equals pi over 2. And because we weren't given an interval, we also need to add plus n pi, because that will happen every period that we go around, every n pi. And then, so that's going to be one of our solutions. But we still need to work on our cosine of x equals plus or minus radical 2. The thing is, when we look at this, and we look at our unit circle, that we see that this does not exist outside it. It's outside of the range of our cosine function. Because cosine, the range of cosine is that x has to be between -1 and 1. But here, the square root of 2, if we look at the square root of 2, we see that the square root of 2 is going to be approximately 1.4, which is outside of that range. So we get to say here that it does not exist, because it is outside the range of cosine. And that is our solution.